Hey guys, here we are, another lecture. I hope you enjoyed the last time, second chapter, and here we are here with the third chapter, and we will talk about a whole bunch of new stuff in this chapter, in this video lecture. What I would like to do first, I would like to check that if any quiz is due today, next week or this week, please take a look at the schedule. Please don't forget to follow the course schedule, so you will be on time for turning in your homework set or your quizzes or any exam date. So please make sure that you are staying on track. If you have any questions, as usual, as always, please do not hesitate to email me. Come see me in my office, room 254, or reach me out somehow, and then we will talk about your problems, your questions, and everything will be clear. Okay, well, welcome to another lecture, another video lecture. Today we're going to talk about cost volume profit analysis. In short, CVP analysis. As you know, the first first page of your lecture notes, it is the lecture outline. We're going to talk about the characteristics of CVP, what we have in there, because CVP is a huge and big tool. It's not just an equation. I will elaborate more. I will talk about it more in detail. Then we're going to talk about break-even analysis, all the equations, situations in the break-even analysis, situations in the CVP analysis, and managerial discussions, and all the interpretation of the CVP analysis. And then we're going to compute different CVP situations, cost, volume, profit aligned situations in hospitality operations. And of course, we're going to follow the in-class examples, and then hopefully everything will be clear. This way, you will get to have enough practice, and then continue along with the lecture. Lastly, we're going to talk about the managerial strategies. We're going to discuss how decision makers in hospitality industry utilize all these tools, how they use all these tools to come up with a straight and healthy financial decision or operational decision in hospitality operations, regardless of the industry. For example, it could be restaurants, it could be lodging industry, it could be cruise lines, theme parks, it could be events, it could be every single subsector of the entire hospitality industry. Guys, I would like to talk about CVP first, okay? I would like to define it, I would like to tell you what it is, and I would like to show you how we need CVP as a decision maker. We need CVP for our operations. Guys, CVP is a tool. It is a concept. Clearly, CVP stands for cost volume profit analysis, and as you can see right here, CVP is utilized to measure internal performance of the hospitality operations based on cost structure, sales volume, and the profit margins. Okay, so CVP combines those three major accounting items to come up with a decision-making process. That's why I call CVP a tool. I call it a concept. It's a big concept. It's a huge tool. It's a big measurement that we're going to utilize. It is not an equation by itself, just like we used to learn until now, or we'll be learning in the future. It is an entire concept. Let me draw something over here on your screen to define CVP more, to visualize what CVP is. Guys, again, let's imagine that this circle is CVP, okay? This is the entire concept we're going to utilize. In CVP, we have break-even analysis, which is the heart of CVP, which is the building blocks of CVP. In this circle, we also have, let me just put it right here, simulations. We have different simulations under CVP along with break-even analysis, okay, for decision-making process. We also have, lastly, decision-making process by itself. Therefore, these three items over here are the main components of CVP. Therefore, CVP becomes an internal tool that's utilized by the managers to come up with an internal performance, to assess the internal performance based on costs, sales volume, revenues, and therefore profits. Okay, so that's what CVP is. And this is a clear definition of CVP. And I'm trying to clean well. Hopefully it doesn't smear on your screen. Guys, there are some assumptions we have to follow. There are some limitations we have to follow when we are dealing with CVP. I would like to mention that. I would like to go over with you major assumptions. Excuse me, major assumptions. So our analysis will be accurate. For example, CVP ignores qualitative factors such as employee morale or weather or customer complaints. These are the qualitative, non-numerical factors. Therefore, CVP ignores them. CVP only focuses on fixed and variable cost. In other words, CVP is decomposed into fixed and variable cost structure, and then this analysis doesn't take any other cost structure, focuses only on FC and VC, as we learn in chapter 2. CVP assumes that variable costs will increase or decrease in a consistent positive relationship with sales revenue or sales volume. Okay. Let me remind you one thing. You don't have to memorize all this, but I do want you to understand all this clearly, because with or without you knowing it, we are going to utilize all these assumptions. We are going to factor those in our equations anyways. Okay. However, it's always a good idea to remember all the limitations and assumptions of CVP for the test, because again, you might see a question as a conceptual question. You might see a question from CVP with a bullet point. So that's a great hint for you for today. Also, sales revenues, they are tied to sales volume. We know that. Okay, if let's say sales volume increased by X%, so does the revenues. We will also talk about this. We will also see this in our examples. Lastly, last limitation we have under CVP, joint costs. Guys, joint costs are not included. Why? Because we know that joint costs are the costs that multiple departments share. Example, office supplies. Okay, kitchen department utilizes office supplies, or sales and administrative department utilizes office supplies. Okay, therefore, joint costs such as office supplies cannot be linked to a specific department. For example, food costs, we can say that food cost has to be listed under F&B department, but not in rooms division. Why? Because rooms division doesn't care about the food costs. That is exactly why joint costs, such as the most prominent example is office supplies, we cannot include those joint costs due to its nature. Okay, so I want you to know this, okay, and I want you to understand this before we get to the calculations, because in calculations we will have to utilize those assumptions and then factor those in our calculations. Therefore, it will be an accurate analysis for a CVP. Guys, we have break-even analysis. Remember the circle that I drew 5 minutes ago. Okay, the circle, that's the CVP, right? What did we say what did I say when I was drawing the circle? Break-even analysis is the heart of CVP. Why? Because break-even analysis is the level of activity in units or in percentages, where it's the level of activity where the operation covers all the costs, all the expenses, but makes absolutely zero revenues and therefore profit. Therefore, break-even analysis is the point where you have no profits whatsoever, but you cover all your costs and it becomes a 0 point. Therefore, this defines the break-even unit. Okay. There's one terminology I would like to mention for the break-even analysis. It's called margin of safety. Okay, margin of safety is the point where, or any other point beyond the break-even point, because remember, break-even point in units or in percentages is the point where you as a decision maker, as an operational director, you cover all your costs and expenses but make absolutely no revenues and therefore profits. Therefore, you're at the 0 point. I will show you in the graph. I will show you in here in the lecture notes, and I will draw the graph, so it will be much more understandable. But again, let me just define them all, and then we will get to the point. Margin of safety any point beyond the break-even point that makes you realize revenues and therefore profits. That's why margin of safety is the point where you want your operations to be located at, because it brings the profits to the operation. It makes the dollars, okay, money. Take a look. Break-even analysis graph. Take a look at this. It might glare a little bit, but I will also draw this graph over here so you can follow both. You know, you can stop the video anytime. You can rewind it, and then you can also go back to it, and then you can listen to the lecture as much as you can. Guys, this is the break-even graph right here. Let me just talk about this using the lecture notes, and I will transfer what we talked in the graph as well. So on the y-axis, we have the total costs. On the x-axis, we have the sales volume. Clearly, from this side, my left to right, it could be your right to left, we have low sales volume to high sales volume, okay? Clearly, zero total cost, and it's increasing in terms of dollars over here. Guys, this line is the total cost line, okay? You can see right here, total costs, right? From 0 point, and this line right here is defined as the total revenues. Take a look. This point where your total revenue intersects with your total cost becomes your break-even point. Why? Because, again, I will tell this one more time, and maybe more, because I want you to understand this, because this graph is the heart of this chapter. Break-even point covers, break-even point is the point, it's 0 point, it's point 0, where you as an operational director, you cover all your costs over here, but you make absolutely no revenue and therefore profits, okay? So, remember from the second chapter, I would like to extend this graph a little bit. Remember from your second chapter that there was a horizontal line, and that line was stable, that line was constant regardless of the sales volume. What was that? It was fixed cost, okay? Fixed cost is defined in this area right here, all right? Therefore, this area becomes your variable costs. And the reason, let me just use a different marker, and the reason we define this graph right here as total cost, because you know total cost is equal to fixed cost plus variable cost. We learned this in the previous video lecture, okay? Therefore, as you can see that this becomes your variable cost, all right? Let me just clean this out, and I will point out again. Okay. So guys, this is the total cost graph, okay? Fixed cost plus the variable cost. We know that this is my break-even point because my revenues are this line I'm just drawing right now, and then the point the point where TR, total revenues, and TC, total costs, are intersecting, this becomes my break-even point. Okay, guys? Guys, any point beyond this point, let me just use the green marker. Let me just clean this real quick. Any point beyond this point is the margin of safety. In other words, you start realizing profits any point after this point, okay? From this point until here, your operation generates revenues. But your operation does not generate a profit until after break-even point, because until break-even point, we have all the expenses and costs, excuse me, all the expenses and the costs that have to be covered, correct? That is exactly why the green line right here, after the break-even point, beyond the break-even point, operations start to realize profits. Okay, guys? Please make sure that you understand that concept clearly. I would like to talk about two important stuff about the break-even, about this graph actually. Again, this graph is the heart of break-even point. I would like to talk about two important stuff. Number one, in this area, look, I told you guys again, in this area, this is my break-even point. In this area, firms start realizing profits, okay? Why? Because all your costs and expenses are covered beyond break-even point, right? Number two, very important. Number two, let me just clean this real quick. Number 2 becomes very important. Beyond the break-even point, guys, okay? You know, I'm just going along in my revenues because of my increasing sales volume. I realize higher and higher revenues. Therefore, beyond break-even points, sales increases at a faster rate than the cost tied to those sales, okay? Therefore, whenever I go or I move far away from the break-even point, I realize, as you can tell, look at the gap, I realize higher and higher amounts of profits. So the profits realized here versus here are not the same. Clearly, profits are higher here. It is because that I am going away, I'm going further away from the break-even points. In other words, I am selling more and more and more and more, okay? Therefore, it made me realize, that operation made me realize more profits than it was, you know, at the points close to the break-even point. Sales increase at a faster rate than the cost associated with those sales, okay? This is the area, you can tell. Number 2, this is the area that you can tell in the graph. Okay, guys? Well, clearly, let's take a look at this. This is the point where total cost is equal to total revenue, and that's my break-even point. Guys, again, let me tell you one thing when I'm cleaning this, because it becomes very, very, very important. So when I'm cleaning the screen, I try to give you guys hints. I try to give you guys a possible and highly suggestible studying strategies, because you don't have to take it, but if, based on my teaching experiences along with my learning experiences, if you visualize what you're solving for, just like I'm going to do in a second right now, if you visualize it, it will increase your learning. Therefore, if you don't understand any quantitative question, or if you don't understand the logic of the question, it is always a good idea to draw a graph or a line or list what's given to you what's given in the question as an information. It's always a good idea, okay? Because in a second we are gonna take a look at the in class we are gonna do the exercises right now, and then you will see what I'm talking about. Guys, we have equations, okay? We have 5 or 6 different equations. I think 5. We have 5 different equations that we can utilize the break-even analysis in the hospitality industry. Let's just talk about those equations first, and then we are gonna jump to the in-class exercises, and hopefully it will be much more understandable, because what I would like to do is that I would like to draw a graph as I walk you through the solutions for every single question we have in this lecture notes. Okay, guys? These are the equations based on different situations in the break-even analysis, not the CVP yet, because we are not in CVP yet, guys. The first one is break-even units. Guys, break-even units, okay, is equal to FC, fixed cost, SP minus UVC in parentheses, close the brackets, okay? SP stands for selling price. In hospitality operations, in mostly lodging operations, sales price is defined as ADR. UVC, unit variable cost. So this BE units is equal to FC minus SP, sorry, FC, let me just back up, excuse me, FC over SP minus UVC. If we would like to find out number of units that needs to be sold to get to the break-even point, we will have to utilize BE units formula, okay? For example, if you like to know how many rooms we have to sell at the break-even point for any decision-making process, we will have to utilize break-even units formula. The second one is BE occupancy percentage. This equation defines the occupancy percentage that we have to achieve at the break-even point. Why do we need this, guys? Why do we need all this? Because we would like to see where I cover all my costs and I don't make any profit, and we would like to see how many rooms I have to sell to get there, how many units I have to sell to get there, and I would like to have the capacity that I would like to fill, okay, to get to the break-even point, and therefore, because any sales beyond the break-even point will be a profit, pocket money in my operation. Therefore, it's always a good idea to know all these so we can we can lay out and create clear and solid financial strategies in our operations. BE occupancy percentage is equal to BE units, which is this guy, over number of units available. It could be rooms, it could be plates, fixed dinner plates, it could be person, it could be seats in restaurants, depending on the question. Okay. The third equation is BE units sold at the desired profit. Okay, guys, we need this equation because sometimes operations would like to analyze what they need to do to make a certain amount of profits. For example, I'm a decision maker, I am the GM or director, and I would like to make I would like to reach $200,000 profit, and I would like to know how many units I have to sell to get that point, so I know how to delegate my stuff and how to create my strategies and how to forecast my operation and do the right budgeting alignments until I get that point. Okay, so which is my target? What was my target? $200,000 profit. Therefore, if you want to see that, if you want to see that number of units that you have to sell until you get that point, guys, this equation becomes the key. We're going to utilize this. BE units sold at the desired profit is equal to, in brackets, in parentheses, fixed cost plus desired profit, DP. DP right here stands for desired profit, over, in parentheses, SP minus UVC. Okay, guys? Don't forget. So what about this then? Let me just scroll down so you can see it better. I am just pointing out in the lecture notes anyways, so you don't have to, you cannot miss it. What about this guy then, guys? What about this? BE additional units sold at the desired profit. Keyword. Additional. Okay? BE additional units sold at the desired profit is equal to BE units sold at the desired profit minus BE units. Meaning, remember this, my graph. Total revenues, total cost. This is my break-even point right here, right? This is my sales. This is my cost right here, guys. Okay? Let's say I would like to make $100,000 profit right here, okay? I know I can find this. The previous equation is covers this area. This area shows how many rooms or units I have to sell until I make $100,000 profits. But what about the additional units then? Guys, additional units, I'm going to utilize a different color right here. Additional units sold at the desired profit is defined this area right here. How many units I have to sell additionally beyond the break-even point until I realize $100,000 profit, okay? So the previous equation, BE units sold at desired profit, is the entire thing right here. I'm drawing it one more time. But BE additional units sold at DP level is this just the gap between BE units and BE sold at DP level, guys. Okay, don't worry. I'm gonna keep drawing the graph based on the equations for every single equation, and it will be much more when we use the numbers with the real equation. With the real question. Sorry, it will be much more clear. Okay, I'm just trying to tell you how the formulas work for different information that we are trying to get out, we are trying to take away, from this analysis. Okay, guys? And the last equation that we are going to utilize for the BE situations, for the BE analysis, is net income or loss. Well, you know the seasonality is a huge thing for the hospitality operations, and sometimes we don't even get to the break-even points because most of the hospitality operations operate at a loss especially during the low season. Correct? Of course, correct. Right? Therefore, if any operation sells less than the break-even point, let's say 100 rooms less than the break-even point, or 800 units less than the break-even point, this equation right here is going to give us the dollar equivalent of selling less than the break-even points, okay? Again, I'm going to take my SP, selling price, multiply by number of units, okay? Number of units sold, take out VC, take out FC, and this will give me the dollar equivalence of selling, selling less than, could be 100 rooms, could be 200 rooms, doesn't matter. Selling less than the break-even points, that's what I determine by using this formula, okay? Okay, so these are the formulas, guys. These are the equations that we utilize, and these are the entire break-even point, very popular information that we take out from the break-even analysis in hospitality operations. Now, it is time to go over equations, it is time to go over in-class exercises. Therefore, what we have been learning so far, we will be able to apply, okay, and we will solve and see real life situations, because most of my exercises and most of the in-class exercises are written based on real life situations, guys. All right. So, Foodle Boutique Hotel, okay, is my example for break-even analysis. Let me tell you this. This is the first question you see in this lecture. What am I going to do? Instead of putting out different in-class exercises for every single BE situation, I would like to extend Foodle Boutique Hotel, okay? So you can see every single BE situation using the one example. You will see what I'm talking about when we get that point, okay, guys? So let's just talk about this Foodle Boutique Hotel. We have 21 rooms available, okay, on daily basis. That's very important, daily basis, because sometimes we might need to adjust daily values to annual values. We have the fixed cost. The Foodle Boutique Hotel has the fixed cost of $210,000. ADR is given as $65, and the UVC is given as $22, okay? So these are the information we have. What we have to do, based on all the information we have for Foodle, okay, there are questions we have to answer. What are the questions? First one, what is the number of rooms required for Foodle to break even? What is this, guys? What is that? This is question number one, okay? Also, what is the annual occupancy percentage at break even for Foodle? This is the question number two. Look, annual occupancy percentage at break even, okay? We have daily basis. We might have to do something. I'll show you. Guys, there are two questions. Again, remember the previous video lecture, okay? We talked about that. There are 4 steps that you might want to follow when dealing with quantitative questions just like this. First step, understand what you're solving for. I am solving for the number of rooms required for Foodle to break even. This is BE units, right? Number of rooms required for Foodle to break even. I am trying to solve for BE units for Foodle. That's number one. Number two, it is very clear annual occupancy percentage for Foodle to break even. Annual occupancy percentage for Foodle at break even point. Therefore, I know I'm solving for BE units. For number two, I'm solving for BE occupancy percentage. So I know the equations. If you go back up right here, I'm going to utilize these 2 equations right here, guys, right? Because this question tells me that I will have to find BE units and BE occupancy percentage. All right, guys? So this was the first step. The second step was to take the right equation to answer the question. We have 2 questions, and we just picked the 2 equations that we have to utilize to solve for this question, guys. The first one is the BE units. The other one is BE occupancy percentage. Okay, guys? Step number 3. We will have to analyze the components of the equations to see if we have all the components given in the question. If we don't, to see if we're going to do additional stuff before we get to the final point. Okay, guys? Take a look at the solution. Let's go step by step. Let me clean this first. Let's go step by step. Okay, what am I solving for? I'm solving for BE units, correct? Again, always a good idea to draw a graph, which I'm going to do right now. This is my TR. This is my TC. That's my break-even point. Well, let me just clean this real quick. I'm going to write something else over here. Just bear with me, please. Okay. My sales right here. Okay. This goes y-axis. Okay, guys. So this is a very simple visualization and representation of the break-even. Okay. For Foodle, this is the Foodle example. Let's say Foodle. I have the right. Yeah, Foodle. Right, correct. This is the Foodle example. What am I going to do? I will have to find out BE units for Foodle. Am I right? Because it tells me that what is the number of units required at break-even point for Foodle? That's BE units. What is the equation for BE units? Take a look at here. Fixed costs over SP minus UVC, correct? Analyze the equation you have. Do you have fixed cost given in the question? Yes, you do, right? $210,000. Take a look at the question. Do you have SP given in the question? Yes, you do. ADR, 65 bucks. Do you have UVC given in the question? Yes, $22. Then all I have to do, guys, okay, I'm going to substitute $210 for FC right here. SP becomes $65. UVC is $22. Therefore, $210,000 over 65 minus 22. When I do the math, I'm going to round it up, by the way, because we are dealing with rooms, okay? We have to utilize even number because we are dealing with rooms, units, okay? Therefore, I need to sell 4,884 units, rooms, to be at the break even on annual basis, guys. Which means I am not realizing any profit until after that point. If you sell 4,000 rooms, you're losing money. You're operating at a loss. If you sell 3,000 rooms on annual basis, you're operating at loss. Okay, guys? Anything after this number, 5,000 rooms, 6,000 rooms, that becomes profitable operation because we just go beyond the break-even point. So 4,884 is number of rooms that I have to sell right now. Well, the extension, the great extension as a decision maker could be that, okay, so I have to sell 4,884 rooms, but what's going to be my occupancy percentage? B occupancy determines, okay, your occupancy percentage at break-even and answer that question. As you know, B occupancy is equal to BE units over number of units available, guys. All right? Do you know what BE units is? Yes. From the preceding analysis, I know what it is. Check mark over here. Do you have number of units available on annual basis? Keyword, annual. You have daily number of units available, but you don't have annual number of units available. What can you find it though? You can. You have number of units available. So let's just plug in the numbers. Break-even occupancy is what I'm solving for, is equal to BE units, 4,884, right here, okay, over 365 multiplied by 21. Why 365 multiplied by 21? The reason is that we have 21 rooms available on daily basis, but we are solving for annual occupancy. That's why we are going to assume that there are 365 days in a given year, okay? That's why I have to multiply 21 by 365. Therefore, when I do the math, when I do a simple division right here, 63.72% becomes my annual occupancy percentage at break even. So, in other words, I have to fill 63.72% of my entire room capacity to get to the break even point, and anything after 63.72% becomes very profitable, profitable to my operations. Guys, here is a discussion, managerial discussion, practical discussions. You as a decision maker, let me just clean this. You as a decision maker, you would like to have lower break-even occupancy. On the other hand, you would like to have higher occupancies. Does it make sense? You want your break-even occupancy as low as possible so you can get that point quicker and faster and sooner. and you would like to have higher occupancy percentages so you can sell more. Therefore, in the end, at the end of this scenario, as a decision maker and operation, you will get to realize higher amounts of profits. That's the key. This is the industry. This is how the industry utilizes these two break-even units and break-even occupancy percentages, guys. Okay, just keep that in mind. Keep that in mind. That's a great takeaway from this solution right here. Let me remind you this: if you guys have any questions about any in-class exercise, don't forget to shoot me an email, okay, or come see me in my office, room 254. Okay. So, as I said, let's just extend a Foodle example. We are still dealing with the Foodle example. Let's extend it. Okay. Imagine that. That's the question I'm highlighted. That's my question right here. Imagine that the management of Foodle would like to have a desired profit of $32,500. Utilizing the information from the previous example above, this one, how many rooms must the management of Foodle sell to reach the desired profit level, including the break-even units? What are you guys solving for? Ask yourself, what am I solving for? Foodle would like to realize some amounts of desired profit. Okay. And they would like to know how many rooms that they have to sell in order for them to realize or generate $32,500 of desired profits. If you would like, just like we talked 10-15 minutes ago, if you would like to know, as a director, as a manager, as an analyst, if you would like to know how many rooms that you have to sell or how many units that you have to sell to be at the certain desired profit, you will have to utilize BE units sold at DP level, guys. Okay. So, since we are extending Foodle Boutique Hotel example, okay, this is our second example. I don't know why I clean the screen, but that's fine. I'm just going to do it one more time. This is my break-even units, 4,884 and 63.72% occupancy, okay? And Foodle would like to make a profit of $32,500, okay? And the question becomes, how many rooms they have to sell from 0 point right here, look, please follow the pink marker. How many rooms they have to sell to make $32,500 profits, okay? In this case, guys, we will have to utilize BE units sold at the desired profit formula, just like you see over here, okay? We have to utilize BE units sold at the desired profit formula, which is equal to FC plus DP, close the parentheses, over SP minus UVC, okay? So this is our formula. When we apply this formula, we will get to find out the number of rooms needed for them to make a profit of $32,500, guys. Do you know what FC is? Using the previous example as well. Do you know what FC is? Yes, we know, $210,000. Do we know what the desired profit is? Of course, it's given in the question as $32,500. Check mark over here. I know what I'm solving for. I pick my equation. Now I'm analyzing my equation to see if I have numbers for every single component. Do you know what SP is? $65 as given as ADR in the previous example, along with the UVC as $22. So boom, that's it. I have every single component of the equation. All I have to do is plug in the numbers, as you see right here, guys. Take a look at this part. Just plug in the numbers, and then I'm good to go. All I have to do is just do the math. Let me just clean this real quick, and then we will proceed. Please follow my fingers right here. $210,000 FC plus DP $32,500 over SP $65, which is the ADR, minus UVC $22. Parentheses first, then the division. When I do the math, 5,640 rooms needed for them right here, okay, so that they can make $32,500 profit, guys, okay? So now you see what I'm talking about, and you see that the benefit of drawing a graph, and it's much more understandable. Let's keep extending Foodle. The Foodle example. Let's keep seeing different scenarios, okay? By using the information from two previous examples, okay? That's why I just put everything over here so we know what we have been solving for Foodle. Let me just label our graph as Foodle as well. Again, how many additional rooms must be sold beyond the break-even point? Keyword, guys, please understand this. Additional becomes the keyword over here. Why? Yes, why? Because whenever I used additional, I am just talking about the gap between BE units, which is this guy, and the BE at DP level. This is the additional part, okay? How many additional rooms must be sold beyond the break-even point? Beyond break-even point to the upside. Beyond the break-even point so that the management can generate $32,500 profit. Excuse me for this. Profit, okay? Guys, all I have to do, okay? I do have the solution equation for this, but all I have to do, I will have to take this number, 5,640, because I have to sell 5,640 rooms to make a profit of $32,500. All I have to do, I'm just going to take this number and then subtract this guy, which is BE units, and then I will be able to find out the additional number of rooms I have to sell. Well, when you take a look at the formula for that, it will tell you the same thing. BE additional units sold at desired profit is equal to BE units sold at DP level, which is this guy, minus BE units, which is this guy, okay? So when I do the difference analysis, guys, 756 rooms must be sold beyond the break-even point on top of this guy, so I can make 32,500 profit. Okay, guys? One last thing. What if Foodle is realizing a bad season? What if Foodle is in a sharp decrease in its sales volume? What if Foodle is in the low season, in the lowest season at all, okay? Utilizing the previous examples, okay? Due to low season, due to any other factors, due to customer traffic, due to popularity, you name it, let's imagine that Foodle is now selling 884 less rooms than its break-even point. So look, the break-even point was 4,884 rooms, right? But now imagine that Foodle is selling 884 less rooms. 4,884 minus 884. Now Foodle is selling 4,000 rooms instead of 4,884. As we know that any point below the break-even point, which is this guy, any point below the break-even point is going to is going to generate a loss. In other words, operations will operate at a loss, okay, at a loss, sorry. Assuming fixed costs will be the same, ADR will be the same, UVC will be the same, because we are utilizing three previous examples, we are extending Foodle Hotel. All we want to know how much money I'm using because of that 884 rooms, okay? Because I'm selling 884 rooms less than the break-even point, and I'm trying to find out this gap right here this time, because this is the net loss area. I'm gonna just do the arrow, okay? I'm looking for this area right now because, again, I'm selling 884 less rooms. Take a look at the solution, guys. 4,000 rooms I'm selling right now, just like I did over here, because this was my break-even point, less 884. Now I'm selling 4,000 rooms, all right? And then the impact of selling 884 rooms, I can utilize this formula right here. Net income or loss is equal to, in brackets, in parentheses, SP multiplied by number of units sold, minus VC minus FC. SP, $65, number of units sold, 4,000, you know. VC 22 multiplied by 4,000 and FC $210,000. What is this? Can you guys understand what I did over here? Remember, VC is equal to UVC multiplied by number of units sold. And I'm dealing with VC. I don't know I don't have the VC in the question. It's not given to me directly, but I can find out how. When I clean this a little bit so I can show you again. I know that VC is equal to UVC multiplied by number of units sold. UVC, I'm sorry, 22 multiplied by number of units sold, which is 4,000. This will give me VC, guys, okay? So when I do the math, again, parentheses first, then the other guys, I am realizing $38,000 net loss just because I am selling. Let me just make it a little bit clearer. Just bear with me. I am just realizing $38,000 net loss just because I'm selling 884 rooms, less than my break-even points, and of course it is hurting my operations, guys. Okay. Bottom line, break-even analysis. I mean, for full example, everything is over here. In real life, let me tell you this. In real life, decision makers don't stick with just one number. In real life, decision makers, which that's you in the near future, they keep extending the possible solutions, possible scenarios to come up with the right decision-making process. What if analysis, okay? Scenario analysis. What if, let's say, occupancy decreases by 20%? What is the implication of that decrease in occupancy on my revenue levels, break-even levels, profit levels? Okay, so they do this. The reason they do this because they get to price their units correctly during the low season, during the peak season, for the group travelers, for the transient travelers, for different type of operational aspects. Okay, guys, that's why BE analysis becomes very critical in that aspect. Okay. The next portion we are going to talk about will be the CV analysis. Will be the CVP analysis, and then I would like to define the CVP analysis. But let me just clean the screen first, and then I will talk about CVP analysis. I apologize if it's smeared on the screen. Trying to clean this clean as possible. Okay.